Hi, I'm Jay Pratap. I'm going to solve question 3 of 6 for the Midsem exam. So the differential equation here is y dash plus 25y is equal to 24 sine t. So it's a non-homogeneous differential equation. So it can be divided as y is equal to y homogeneous part plus y p part. Now the homogeneous part is y double dash plus 25y is equal to 0, which represents a basic undamped oscillation, which is m y double dash plus 25y is equal to 0, where m is equal to 1 here. So the motion equation of a mass spring system, of an undamped mass spring system, is y is equal to a sine omega t plus b cos omega t. Okay, sorry, this is k, and k here is 25, where omega is under root k by m. So omega here is 5. So we get the equation, the solution of the homogeneous equation as y is equal to a sine 5t plus b cos 5t. Now taking the yp part, so yp is equal to 24 sine t, which we take as a sine t plus b cos t, and then we find y double dash, which is a cos t minus b sine t, then y double dash is equal to minus a sine t minus b cos t. So substituting these in the first equation gives us minus a sine t minus b cos t plus 25 a sine t plus 25 b cos t is equal to 24 sine t. Taking this in common, we get minus a plus 25a sine t plus minus b plus 25b cos t is equal to 24 sine t. Comparing both the sides, we get minus a plus 25a is equal to 24. So which gives us a is equal to 1, and minus b plus 25b is equal to 0. So which gives us b is equal to 0. So the equation solution we get is 1 sine t. So the whole solution of the equation, general solution, is y is equal to a sine 5t plus b cos 5t plus sine t. Now we will use the initial conditions and find the particular solution. So the first condition is y of 0 is equal to 1. So 1 is equal to 0. This part, so cos 5t becomes 1. So b is left, and this again gets 0. So we get b is equal to 1 from the first condition. The second condition given to us is y dash of 0 is equal to 1. So our y dash is a of cos 5t minus b of sin 5t t plus cos t. So using the initial condition, get 1 is equal to, this gets 5a as cos 0 is 1, then sine 0 is 0, so this part gets cancelled out, and then this again gets 1. So we get A as 0. Now using the values of A is equal to 0 and B is equal to 1, we get the particular solution. Y is equal to cos 5t plus sin t. This is the motion equation of the mass spring system. Now they have also asked to sketch the graph. Sketch the graph of the solution curve and y is equal to yp. So y is equal to yp is y is equal to sin t. So that's basically this. So the solution curve cos 5t is added to sin t. So which gives us the value of cos 5t, variable cos 5t is added to sin t graph. And the frequency of cos is 5 times more than sin t. So basically in the curve of sine graph, cos graph is added with 5 times more frequency than sin t. So we get a graph like this. So in one cycle of from one crest to one trough to another trough, we would have 5 times the frequency of the cos. So 1, 2, 3, 4, 5 from here to here. So the graph of solution curve would be so this is how the solution graph would be, containing 5 times more frequency than of a sin t. And then the steady state. So as the system here is undamped, it will never stop or come to a rest or a steady state. Till infinity, the graph will keep going on and it would never come to a steady state.